Hello, is everyone excited to be here? Woo! Welcome to our first ever Dev Day. I'm really thrilled to have you folks join us. And we are humbled by the community response and are super excited about this amazing turnout. And this week at Snowflake Summit, we talked a lot about our new products, our vision for our future with customers, prospects, partners. But today, it's for the builder community. It's for all of you. Snowflake customers or not. We want you to connect, share ideas, and skill up in data and AI. We want you to get inspiration from each other and from the industry luminaries we have lined up this afternoon. I took a picture of myself with Andrew, to the side. I was like, oh my God, I'm with the demigod. I'm a developer. I'm a software engineer at heart. And I love the little things that technology can do. I'm genuinely super excited when I check out new things. I wrote my first Streamlit app. It was all of 10 lines long. And I was like, holy cow, this thing runs inside, Snowflake. I don't have to deploy a server. It just works out of the box. And of course, I shared that with Adrian. I was like, oh my God, you're writing a Streamlit app. And I get super inspired when folks like our PM director, Jeff Holland, he made this video. This is this weird idea that I had. Hey, let's use container services to do some video transcriptions and then get structured attributes from those transcriptions. Use Cortex Search to put it in and have a chatbot. Okay. And he made that happen in a couple of hours. And I could then install an app to do the very same thing also in 10 minutes. And I could tinker with it. And these are all great things because we are able to grow the community of developers that build on Snowflake. It's a strategic priority for us. So we're evolving and investing to better meet the needs of builders like you. And although we started as a as a closed source product with an enterprise focus, we are opening up. We are becoming an application platform with a healthy dose of open source and community-led development. And you heard it before, we just concluded our first international AI hackathon featuring Arctic, our own true open LLM. And congrats to the winners. But we began investing in our developer program 5 years ago to support developers building data-intensive applications. It's our sweet spot. And the growth has been amazing. Thousands of people are powered by Snowflake already. And we partner closely with these companies at every stage to help them build, but also scale their applications with customers, help them generate revenue. And whether it's providing build and design resources, specialized support, or go-to-market, via the partner program, we are aligned with the growth of these partners. On Snowflake, you can have fun building and creating amazing startups that can change the world with our support. And hundreds of startups are building their entire businesses on top of Snowflake with a handful of them, including folks like Maxa, My Data Outlet, and Relational AI, earning millions from distributing their apps on the Snowflake marketplace. I met Molham earlier yesterday. I was like, dude, Snowflake ran an unpaid commercial for you for 25 minutes. That's what the keynote yesterday was. And we also make equity investments in these startups because we want to align long-term incentives. Earlier today, on this very stage, Big Geo, Scientific Financial Systems, and SignalFlare.ai were the finalists of our 4th annual startup challenge, and they competed for up to $1 million in investment from Snowflake winners. And the big winner is, big congrats to SignalFlare.ai for winning the startup challenge. Please give them a big round of applause. And with our Snowflake Native App Accelerator Funding Program, we have partnered with 10 leading VC firms to invest up to $100 million in early stage startups that are building native apps. We are also investing in training for our builders to help them skill up and grow their careers. Just this week, we launched the North Star education program from self-paced online courses and in-person workshops in all regions of the world. All of this for free. And check out the courses we just dropped on Coursera to start building on Snowflake. I feel very fortunate that we are all at the center stage where data, AI, technology is still transforming the world. It's a thrill, it's a privilege, it's also a responsibility. And we are very grateful to many of the luminaries, there's no other word for them, that are driving the transformation and are joining us here today as we kick off our Luminary Talk series. And I am delighted to welcome our first luminary speaker on stage, founder and CEO of Landing AI, co-founder and chairman of Coursera, and a former Google colleague. Please welcome Dr. Andrew Ng.
Hey, thanks for
Welcome. Andrew, it's a privilege, it's an honor, it's a thrill to be on the same stage as you. You've been around AI for way longer than most people. What was your AI aha moment? By the way, I went to grad school at Brown, and everybody then told me, this is like 20 years ago, 25 years ago, everybody's like, don't touch AI. Nothing will come out of it.
Wow.
They were wildly wrong. But what was your big aha moment for AI?
I remember when I was a teenager, my first job was as an office admin. And I just remember doing so much photocopying, like photocopying. And even then as a teenager, I thought, boy, if only we could, do something to automate all the photocopying I had to do. Maybe I could spend my time on something else. That's why I wound up pursuing computer science and career in computer science and AI. And in fact, your remarks just now, I'd actually forgotten. I saw you operate the Google Ads business. Now you're CEO of a huge company. When you mentioned that you were writing Streamlit code, I got to throw all of that. I think,
tech can actually be fun. That Streamlit one was fun. I was so excited to watch the video of Landing AI and Snowflake working together, Landing Lens, that we posted together on LinkedIn. That to me is like pure joy. As we're talking about AI, I have to ask, is there a $1 billion model coming, you think, where people need, 50,000 H100s to get started, step one?
Yeah. I definitely, some people are thinking that way. It'll be interesting to see if we get there. Part of me feels like there could be cheaper, less capital intensive, less energy intensive paths as well to build highly intelligent systems. But on the other hand, I don't think we've squeezed all the juice we can out of sheer scaling laws, so that's also worth pursuing. And I just say, I really appreciate the work that Snowflake's been doing as well on open sourcing Arctic. I think, we need more contributors to do that kind of thing.
To me, good things happen when technology spreads broadly, when lots of people can do the same thing. Otherwise, it gets naturally falling into the hands of a few, mean that we don't get broad-based benefits. So, for me, that's the reason why I hope models stay somewhat less expensive so that more people can develop, more people can tinker and push all of us forward. Couple more questions. You were at the US Capitol recently where there was this debate over open source model, AI regulation. Where do you land in this debate?
Yeah, at this moment, I'm actually very worried about California's proposed SB 1047, which I think would be very stifling for innovation in open source. So I feel like there's a technology layer, and technologies are useful for many applications. Then there's an application layer, which tends to be specific instantiations of technology to meet a customer need. And for general purpose technology like AI, it's impossible to stop AI from being adapted to potentially harmful use cases. So California's SB 1047 poses a specter of liability if, say, someone open sources a model and someone finds some way to adapt it to nefarious means. And I wish we could guarantee AI will never be used for bad things. I wish we could guarantee computers will never be used for bad things. But if you say that any computer manufacturer is liable if anyone uses your computer for something bad, then the only rational move is that no one should make any more computers, and that would be awful. So I think Washington, D.C., fortunately, has gotten smarter. I feel like over the last year, the White House executive order, I had some concerns with, but I think the House and Senate have gotten decently smart. The Schumer gang actually figured out AI and is more pro-investing than pro-shutting it down. But I'm actually really worried that here in California, which is home to so much AI innovation, there's this truly awful proposal on the board. It's just passed the Senate vote, going to the Assembly next, that I think would be awful if it passes. So we'll see. All of you, go fight the fight. SB 1047 is an awful idea.
People forget. I think it is really important to reiterate what Andrew just said, which is, all of us need to understand that AI is a technology. Yes, there'll be good things that come from technology, but there'll also be bad people that use technology. We need to make sure that laws cover those things, but not, either make a hero or a villain out of technology. There are going to be all kinds of different use cases that we as a society need to be ready for. Okay, please.
And to be clear, I'm pro-thoughtful regulation.
That's right, that's right.
Figure the harms, regulate against harmful applications. I'm pro-thoughtful guardrails. But when regulations puts in place impossible requirements, then I think the only thing that will do is stifle technology and stifle innovation.
That's correct. And that's the thing to remember, which is premature regulation can be super stifling because it introduces so much risk. Okay, topic du jour. We know that, language models, whether it's GPT-3 or 4 or, the Llama models or Arctic, were big steps forward. But the buzz these days, which you have written about, which you have thought a lot about, is agentic AI. Can you tell us what it's all about?
Yeah, so I think AI agents, which I'll chat a little about later with the presentation as well, is significantly expanding the set of what can be done with AI. I feel like with a set of AI tools and large language models that are working, and the work on Cortex is brilliant, frankly. And I find that when we build on top of these tools, we can even further expand what is possible with a large language model. And in terms of AI technology trends, I think for any builder, anyone building AI, if I had to pick one thing to keep an eye on, I would say is AI agents. I think there's more than one thing we should keep an eye out on, but if I had to pick my top one, this might be it.
Well, we should all be saying agents, 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 but we won't. With that, I will leave the floor to you. Andrew's going to do a few remarks. You'll all love hearing from him. As I said, this is an incredible privilege for me to have Andrew and the other amazing guests that are going to be here. I hope all of you have a lot of fun listening to him, learning from him, asking questions, and of course doing cool things yourself.
Yeah, thank you. And I just say, really want to thank Street and the whole Snowflake team. My team, Landing AI, building Landing Lens as a native app on Snowflake. Yep. Really thinking about how to hopefully do more things with Cortex. It's been such a brilliant platform. So
we are super excited to be working with you and your team. Thank you. Congratulations.
Thank you.
Good luck.
Woo! Thank you. Thank you. So, because this is a developer conference, I want to take this opportunity to share with you some things about AI agents I'm excited about. And I'm actually going to share some things I've never presented before. So there will be new stuff here. So, AI agents, right? What are they? Many of us are used to using large language models with what's called zero-shot prompting. And that means asking it to write an essay or write a response to a prompt. And that's a bit like if you imagine going to a person and saying, could you please write an essay on topic X by typing from start to finish all in one go without ever using backspace. And despite the difficulty of writing this way, I can't write that way. Despite the difficulty of writing this way, OMs do pretty well. In contrast, an agentic workflow is much more iterative. You may ask an OM, please write an essay write an essay outline, and then ask, do you need to do any web research? If so, go search the web, fetch some info, then write a first draft, then read your draft to see if you can improve it, and then revise the draft. So with an agentic workflow, it looks more like this, where the algorithm may do some thinking, do some research, then revise it, and do some more thinking, and this iterative loop actually results in a much better work product. And if you think of using agents to write code as well, today we tend to prompt an LLM, write code, and that's like asking a developer, could you type out the program and have it just run, from your typing from the first to the last character. And it works surprisingly well, but agentic workflows also allow it to work much better. So my team collected some data that was based on the coding benchmark called Human Eval. Human Eval is a standard benchmark released by OpenAI a few years ago that gives coding puzzles like this. Given a non-empty list of images, return the sum, and that turns out to be the solution. And it turns out that GPT 3.5 on the evaluation metric, parsec K, got it 48% right with zero-shot prompting it to just write out the code. GPT-4 does way better, 60%, 67% accurate. But it turns out that if you take GPT 3.5 and wrap it in an agentic workflow, it does much better. And so, and with GPT-4, that does also very well. And so to me, one thing I hope you take away from this is, while there was a huge improvement from GPT 3.5 to GPT-4, that improvement is actually dwarfed by the improvement from GPT 3.5 with an agentic workflow. And to all of you building applications, I think that this maybe suggests how much promise an agentic workflow has. So my team at Landing AI works on visual AI, and I want to share with you some late-breaking things. I've never presented this before. We just released this as open source a few days ago on what I'm excited about building a vision agent. So the lead of this project, Dylan Laird, is an avid surfer, and so he looks a lot at shark videos. There's a shark, and these are surfers kind of swimming around. And Dylan was actually interested with videos like these, how close do sharks get to surfers? And this is a video generated a video like this. The shark was 6.07, 7.2 meters, 9.4. Now it's swum far enough away, so we switched the color from red to green, and the surface more than 10 meters away from the shark. So if you were to write code to do this, you run object detection, do some measures, finding boundary boxes, plot some stuff, you could do it, but it's kind of annoying. Take several hours to write code to do this. So I want to show you the way we built this video, which was we wrote a prompt. Can you detect any surfboards or sharks in the video? Draw a green line between the shark and the nearest surfboard. Assume 30 pixels is 1 meter. Mark the line red, blah, blah, blah. This was the instruction given to the vision agent. Given this, the LLM, you prompt, writes a set of instructions that breaks the task down into a sequence of steps, extract frames by using the extract frames tool and so on. This is a sequence of steps to do that task. After that, we retrieve tools. Tools means function calls. So for example, save video, right, as a utility function that saves the list, and then we retrieve a long description, of the save video tool or the save video function. And similarly for the other tools, closest box distance to measure the distance between the shark and the surfer. And then based on that, we end up generating code, fully automatically generated, that when run, results in the video that you just saw. Right? So I'd like to just dive a little bit deeper into how this works. So we built the vision agent to work as follows. You input a prompt. This is a slightly simpler prompt than the one I used just now, but calculate the distance between the shark and the nearest surfboard. And the goal of our vision agent is to write code to carry out the task that you prompted it to, so that you can then feed it a single image and have it generate the desired outcome. And similar to agentic workflows on writing non-image code, we find that this works much better than zero-shot prompting for many applications. Moreover, we found that for a lot of image users, for example, if in Snowflake you have 100,000 images, then having code that you can very efficiently run on a very large set of images is important too, because once you have the code, you can take a large stack of images or maybe video frames or whatever and run it through a relatively efficient piece of code to process and get the answers. And I want to share with you how our Vision agent works, and it's open source. So take a look, give us feedback, maybe help us improve it. But the Vision agent is built with two agents, a coder agent and then also a tester agent. But with a prompt like this, a coder agent first runs a planner to build a plan that lists out the steps needed to complete the task. So, load the image, use a tool to detect the object, calculate distance, and so on. And then it retrieves a detailed description of each of these tools. Tools means functions. And then finally, generate the code, right? And I don't know if some of this seems a little bit too magical almost, but all the code is on GitHub. Take a look at it. Take a look at the specific prompts we use. You might be surprised when you look at the details how, all of this stuff seems magical maybe the first time, but look at the code and look at the prompts and it turns out that when you do this, here are a few other demos. This says detect every person in this image, figure shows wearing a mask, output a Python dictionary. So generates a bunch of code. Here's a Python dictionary, 8 people are masked, 2 people are unmasked. Or here's a different prompt to actually generate a visualization, plot the detections, and so on. So this is a new piece of code, all automatically generated. And, I actually missed the unmasked people, the object detection thing, found the unmasked people. One more example. Oh, this one's kind of fun. Analyze the video every 2 seconds, classify if there's a car crash or not, output JSON, showing is there a car crash or not. So car crash videos are always, well, I don't think anyone was hurt, but 16-second video. It's coming. There's a car. Fortunately, no one was hurt, I think. And if you do that, here's the code on the right. And it processes the video and outputs the JSON showing, at this timestamp, there was no car crash. At this timestamp, there was a car crash. Right? And so the feedback I'm hearing from quite a lot of people, from my internal team and some users is, yeah, I could have written the code myself, but it would have taken me a few hours and you can now get this done. I find that in computer vision, we use lots of different functions, and honestly, I can never remember, right? What functions to use, what's the syntax, and this really makes the process of building visual AI applications much easier when it works. And I want to share just one other thing that makes the performance better, which is use the tester agent. So I showed you the coder agent, and it turns out that you can prompt an LLM to say, write some tests for this, and or write text code. And based on that, it can execute the test code. Right now, our test code is often type checking, so it's a little bit limited, frankly. But even with that, we can execute the test code, and if the test code fails, feed the output back to the coder agent, have it do a reflection and rewrite the code, and this gives it a further performance boost. Oh, and I should say, in terms of academic literature, the 2 research papers that we counted on the most is the agent coder paper by Huang et al., and then also the data interpreter paper by Hong et al. So you can take a look at those papers if you want to learn more about these techniques. And so just to show one last demo, this is can you detect the cars and motorbikes in this video every 2 seconds. We wanted it to highlight, so this is actually for CCTV videos, kind of put together into a video. Common thing people want is to just highlight the interesting parts to look at. So long prompt, YouTube link, so it creates instructions, like so. Retrieves tools. It turns out the code doesn't work, right? So the code, maybe I'll show you this one. The code actually fails a few times. Here, when running it, there's an index error, trace back. So we feed all these error messages back to the LLM. Fails the second time, fails the third time. It turns out the third time it fails, no module named PyTube. And so the last thing that fixes it is it's figured out, to do pip install PyTube. And then this actually fixes it, runs the code, and then you have this kind of, highlighting in the CCTV agglomerated video which of the 4 videos has more than 10 vehicles and that you should look at, right? So, I'm excited about agentic AI as a direction for many applications, including coding and vision and the visual agent, which is what we've been working on. Just to share some limitations, it's very, very far from working all the time. In our experiments, tool failure is probably one of the most common failures. We use a generic object detection system, grounding dyno, that sometimes fails to detect objects. Here is miss a bunch of yellow tomatoes, common failure. One of the things I was excited about Landing Ice collaboration with Snowflake was we recently built Landing Lens, which is a supervised learning computer vision system as a Snowflake native app. But I think with supervised learning, we were able to mitigate some of these errors. And then, it's not good at complex reasoning. So here, if you say each bird weighs half a kilogram, how much weight is on the fence? With this example, system naively detects all the birds, but doesn't realize that one of the birds is flying and won't put weight on the fence. But it turns out if you modify the prompt to say ignore the flying birds, it actually gets it right. And I feel like today, Vision Agent, we've released it in beta. It sometimes works, sometimes doesn't work. It's a little bit finicky to the wording of the prompt, and sometimes you do need to tune the prompt to be more specific about the step-by-step process. So I wouldn't say this is, brilliant, amazing software, but sometimes it works, and it works. I've been really delighted and amazed by the results. I just want to mention, hey guys, you stand up. The team that built the Vision Agent is actually here today. Dylan's a surfer, standing in the middle, and Asian Shankar. So I hope you catch them. You'll learn more about this either here or at the Landing AI booth. And is also online at va.landing.ai. And is also released a core engine as open source. And I feel like AI agents is a very important, exciting trend. And we're making this small contribution to open source to hopefully help everyone. And I hope that together we can make agents much better, and this will significantly improve what we could all do as developers. So let me say thank you all very much. Thank you. Let's see, so someone told me that we have a couple minutes. Oh, I think Lucas from Weights and Bias is coming on. I think we have a couple minutes from Q&A. If people have a couple of questions, I'll take them quickly, and I should get off stage so you can hear from Weights and Biases.
Thank you very much for giving us a very concrete example to explaining the workflow. Really appreciate it, Andrew. Thank you. And I have a very quick question regarding to agentic AI. So, do you see, first the question is, other than Vision Agent, do you see agent can be used in other applications? That's number one. The actual concrete in application, the agents, that's number one question. Number two, would you say agent is just a sort of specialized AI while giving the language model or any other models we're having, it's more like a generic AI? Thank you.
No, thank you. Yeah. So thanks. So let's see. What I'm seeing is that AI agents are being used for many, many different applications. I feel like some of you may have seen the splash that Devin made on social media, although there was some discussion about the nature of that announcement. But this Open Devin is an open source coder agent, and there's a lot of research on coder agents. I'm seeing teams doing legal work, for example, analyzing complex legal documents, use agents to analyze complex legal documents. I think AI research agents can go onto the internet, do a web search, synthesize lots of information, and write a document with deep research. That's really taken off. I feel like, I actually play around quite a lot. I'll use agentic platforms like TrueAI, AutoGen, sometimes LangGraph. And I'm actually seeing lots of people build lots of applications on top of these frameworks. And right now, I find that many agents tend to be built for a specific purpose, but it'd be interesting to see, if there's a single, very general purpose agent. I think it's exciting. Oh, for a lot of agents, I think that we're just crossing the threshold from toy novelties to being useful. For example, AI research agents, right? They've been around for a long. Go on the internet, do a web search, write a research paper for you. I think like 3 months ago, it was great to play with, but just in the last couple months, my friend Monica Lam from Stanford, her research lab released Storm as an open source software. I feel like, yep, this is actually getting to be useful. So I think just in the last few months, I'm seeing a lot of these applications cross from being fun novelties to being actually pretty darn useful. Now I'll just take one more question, then I think I should get off stage. No, okay. All right, I think they're saying all the time. So thank you all very much, and it's really nice seeing all of you. Thank you.